Alright, this is section 3.7. This is part 2. Okay, we're trying to check if these two functions are inverses of each other. I'm plugging g into f. Okay, so I'm going to take the square root of 2x plus 7, wherever I see an x in that function. I'm going to plug in 2 times x squared minus 7, like I've done so here. And then I'm going to simplify this. Okay, so this is going to be 4x squared minus 28 plus 7. So this is going to be 4x squared minus 21. Okay, it doesn't look like I can do anything else with this. So because this one didn't come out to be x, that means that these two functions are not inverses of each other. Okay, now let's look at the domain and range of inverse functions. So the range of the function f of x is the domain of the inverse function f raised to negative 1 of f. The domain of f of x is the range of f of raised to negative 1. Okay, so what it says is basically for inverse functions, you're going to switch the domain and the range. So if we had f of x, and this was our range, this is our domain, and the inverse of x, well, now, say it's y, we'll say this is x. Well, now the range for the inverse is now x, and the domain for the inverse is now y. They just completely switch. That's basically what that is saying. So let's take a look at this table here. We're going to fill in the missing values. So find f of 9. Now remember this f of x. So what they're saying is here that x is equal to 9. We're trying to find y, really. Okay, so we go to the x values, go down to 9. That means that f of 9 is really just 5. Okay, and then we're going to find if f of x is equal to 6, then x is equal to. Okay, so f of x is equal to 6, so that means x is equal to negative 2. Then we get to the inverse of f of 1. And now remember, the inverse is everything is switched around. We're used to saying that inside here, well, that's x, but since we're talking about the inverse of f, that's really y. So what we need to do is we need to come to our y values, which is the same thing as f of x, just a really fancy way of writing y. I need to go down to 1, and then this is going to be the inverse function of 1, so negative 7. Okay, if the inverse function of f of x is equal to 5, then x is equal to, okay, remember everything's backwards here. We're used to saying this is equal to y, but this is actually equal to x because it's the inverse. Okay, so this is really x is equal to 5. This is really y. It's just because we're talking about the inverse, everything is flip-flopped. Okay, so we need to go to our x values, and we need to find 5, so our answer is 8. Okay, so there's all of our answers to this table right here. Okay, now let's look at the inverse functions and their graphs. By the way, when we're talking about here the domain and range of the inverse function, we switch everything. When we're looking for inverse functions, that's why we were taking, setting everything equal to, changing this to y right here, and then switching the x and the y's. For every single one of these, we switched the x and the y's. And that's because for the inverse functions, the domain, which is x, and the range, which is y, they switch when we're talking about inverse functions. So that's why we did that in those first few examples there. Okay, now we can go and look at the graphs. Okay, so remember when we were talking about inverse functions, the very first thing we said is, number 1, they have got to be 1 to 1. Okay, so they've got to be a one-to-one function. So in this example, we're looking at x squared. And we know that x squared looks like a U shape. It's a parabola, so it should keep going this direction. But the horizontal line test says that it's a test for the one-to-one function, for a function being one-to-one. So if I have a horizontal line, if it crosses twice, 1, 2, well then that's not a one-to-one function. So it says right here, we're going to restrict the domain, or we're going to cut off part of this function so that we do have a one-to-one function. Now if this is just this blue function here, anywhere I draw a horizontal line, it's only intersecting that line, horizontal line, just one time. So now we have a one-to-one function, which is the premise for looking at inverse functions. Okay, so restricting the domain from 0, so starting right here, going out to positive infinity for our x values. Remember, domain is x values. Okay, so this makes the function one-to-one, and it will obviously pass the horizontal line test. So it has an inverse on this restricted domain from 0 to infinity. We already know that the inverse of the toolkit quadratic function is the square root function that is, and if you didn't know that, that's fine. It's the square root of x. Okay, so this kind of teal, this function right here, that is the square root of x. Whoops. There we go. Okay, so the x squared and the square root of x, those are inverses of each other. So we're going to put both the x squared, while it's restricted from 0 to infinity, and the square root of x, which it goes from 0 to infinity anyway, on the same graph, and then compare them. So we notice a relationship. The inverse graph is a graph of x reflected about the line y equals x. Okay, so we take this line right here, y equals x, and we cut the picture in half based on this line right here, and they're mirror images of each other, which we call, they call it the identity line. I don't really go much into that. Okay, now that's what the inverse functions graphically are going to look like. When you have one function and you're trying to find the inverse, well, when you graph those, and if you have to restrict them, then what they're going to do is they're going to look like mirror images of each other across this y equals x line. Okay? Now let's look at this right here. Determine if the two graphs, or the functions in the graphs, represent an inverse function. Now here is our y equals x line, this dotted line right here. Now if I cut this picture in half, it does look like it's an exact mirror image of each other. So because of that, and we've got one function here, one function right here, and then we've got a different function right here. Okay, now that looks like a mirror image of each other. So because of that, yes, these two functions are inverses of each other. Now let's look at this one. Here is our line y equals x. So if I cut the picture in half right here, they are not mirror images of each other. So because they're not mirror images of each other, these are not inverses of each other. Okay, now this one, we're trying to determine the inverse for the graph below. Now I need my y equals, and it goes through the origin, y equals x, and you can graph this because whatever y is, x will always also be. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Notice I'm getting off just a hair over here, so I can fix that. -1, -1, -2, -2. Got off just a hair on that one. Okay, so there's y equals x. So I need the mirror image of this over here. Okay. Notice that starts at 5, so I'm going to start at 5 here and go this direction. Now notice that is a mirror image of each other. Okay, and that's exactly what it would look like. There's our original function. There's the inverse function of the function that we just had.